will see the today's LeetCode problem, which is binary subarrays with sum. So this is a medium problem. Given binary arraynums and integer goal, return the number of non-empty subarrays with some goal. A subarray is a continuous part of the array. So this is 1 0 1 0 1 and the goal is 2. So here is non-empty subarrays. So for that we have to find the number of subarrays which has the summation 2. So let's suppose there is 1 0 1 0 1. So we need to find the number of subarrays for the summation of 2. So we can see that 1 0 1 0 this 1 0 1 is a one subarray, 0 1 0 can be second subarray, 0 1 0 1 can be third subarray, and this 1 0 1 can be a fourth subarray. So for that I think we can use a hash map for that. Like whenever we get a summation, we will store it in our hash map, and whenever we find any sum, we will minus and see whether that summation is already existed in my map or not. So let's suppose there is take a summation 0. Now the plus 1 is there. Now summation becomes 1. I will insert into my map, which is 1, right? So now my sum becomes 2. 1. Now it becomes 2. Now my sum becomes 2. So when my sum is equals to 1 on second index, I will check firstly that whether my mp dot count, which is equals to this sum minus goal, is exist in my map or not. So this 1 minus 2 is equals to minus 1, which is not exist in my map. So we will not include in that answer, right? So for the summation 2, I will check that whether this sum minus goal is exist in my map or not, which is equals to 0, which is also not included because I have not included 0 in my answer. So but this is an answer, right? So for that I need to include this one here also, right? So now my answer becomes 1 because we achieved a goal, right? Now my sum becomes again 2, and now in that case I need to check whether this goal is achievable or not. So if we see that goal is again achievable, now we get the correct answer, right? And now we will get the summation value is 3, which I will check again that whether this 3 minus 2 1, which is equals to 1, which is exist in my map or not. So we will see that whether this 1 is exist 2 times in my map. So it means that the summation 1 is previously the summation of 1 comes 2 times this. So we will include an answer that 2 times 2 plus and 2 is equals to 4. So if we see our answer, which is equals to 4. So why I'm seeing this previous summation? So because it can happen that sometimes you have, and sometimes that the previous sum already exists and you just need to see that, right? You just need to include in the answer, right? So what will the time complexity will be? The unordered time complexity will be O of n, because unordered map take O of 1 for searching, and the space complexity will be depends on number of distinct characters, which is only 0 and 1. So it is O of 2, which is equals to O of 1, right? So let's code it. So let's take an unordered map. Let's define the size. Let's take a summation 0 for storing the summation while iterating. So we will traverse from starting to end, and this we will store it the summation. Now we will check whether this sum minus goal is already exist in my map or not. So I need to also declare an answer variable to store my number of counts. So if it is exist, then I will store the count of that summation in my answer, because it will be all the part of the summation which is include my answer. I will store this summation value along the way, right? And lastly I will simply return my answer, right? So if we see this zero condition, so this first summation is 0, I have included, and this sum minus goal is 0, so I need to also include this summation, right? That amp0 should be 1, right? Because when sum is equals to goal, then it becomes 0, so I need to also include it first in my answer, right? So let's run it. Yeah, it passed. Yeah, bingo. So there is another method. So whenever you see this subarrays or subarrays type, you mostly hit the sliding window concept, right? This is the hashing method, but you can also use the sliding window concept here. The summation, because you need to achieve a goal. So when you use sliding window, you just you take a 2 pointer, that you will just see that 1 0 1 0 1, right? So what we will do that in sliding window, that fix a we will fix a window, and whenever we get a sum in that window, we will whenever we get greater than the sum in that window, we will slide that window to the value where we reach the summation equals to goal, right? Like when like 1 0 1 and again 2, so this 2 becomes equals to goal. Now when we iterate again 3, now this summation will be greater than goal. So we are so our window will be only this 1 1 2. So we need to slide the window to so that the summation equals to goal always, right? So in this question, you you cannot simply apply the sliding window like normal sliding window, right? You need to do some uh, tricks here using sliding windows. Why? Because this is not a normal nums value, this is the binary value, right? 1 0 1 0. So what happen in one what happens during what happens in case of zeros, uh, it gets add and does not affect the summation value, right? But it affects the number of subarrays. So normal sliding window will not able to solve it. So what we can do is we can simply find the summation atmost k, right? What do you mean? What I mean is that we will find the summation which is we find the number of subarrays which has atmost sum less than 2 equals to 2, and we will also find a summation value. We will also find the number of subarrays whose sum is atmost 2, and we will also find a number of subarrays whose sum is atmost 1. And what will I do, that I will simply minus both of them, right? This b, and let's suppose this is a and this is b, and we will simply a minus b, which is equals to our answer. So what will I get? That I will get the number of subarrays whose sum is equals to 2, right? Atmost 2 means 0 1 2 and 0 1, right? So if I minus from a minus b, then I will get whose sum is equals to 2. Understood, right? Now uh, the sliding window approach can be applied on this, right? So for that, let's take a num.size. So just take the and start value 0, answer value 0, and we will also iterate in 0 less than n plus plus. Also need to take a summation value, right? So what will be the benefits from using this sliding window? We will not use an extra space which was using in previous approach, that is unordered map. That was not costing much extra space, but it was costing an space. So that will be completely of one, right? This will be completely of one. So this will be nums, and so we will check that whether this start is less than end and this summation value is greater than goal. If it is, then we will simply minus it from goal, and I will also increment this start value. So if I get my summation equals to goal, I will store this and minus start value, right? This sum is equals to goal. Then what value is stored? That the whenever we will store the total number of the frequencies, right? Like this is 1010, so 1, so 10100. So when this will decrement, so I will start point becomes here and end point is here, so I will store this and minus start value, right? Because I need to store I need to calculate the total number of subarrays from whose sum is 0, 1 or 2, right, whose sum is greater than equals to goal. Okay, so this should not be here, sorry, which is not equals to 0, 1 and 2, right? Because let's suppose 1, 1, 2 and 3, the start variable is here starting, and after 2 it comes here. So 0, 1, 2, 3, 4. Now 4 minus 0, sorry, yeah, right, yeah, right. 4 minus 1 is equals to 3. So yeah, right. So 4 minus 1 is equals to 3, which is equals to there are total number of 3 arrays in between these two, which is equals to, so let's dive in. Let's take an answer variable, try to print it. I'm just checking that whether it is coming correct or not for the summation at most k. I'm trying to find this, right? I'm trying to find the first part, and again the same concept will be applicable to second part. Okay, right. So here comes 9. Let's see how it comes 9, right? So in starting 1, 0, 1, 0, 1. So we need to find the goal 2 here. So the summation, we will need to find the subarray which has all the summation 0, 1 and 2, right? So 1, 2, okay, so this will be 9. So this will be 1, 2, 3, 4, right? Then, and what will it comes when we will search for goal minus 1. Yeah, it becomes 5. Now 9 minus 5 is equals to 4, which is correct, right? So we are on the right track, right? So yeah, let's so what I can do is I will simply make this sliding window is another function and just return an answer. We can do that, right? So what I can do is I will simply remove this and I will simply get an answer for this. This is, let's take an answer, and this answer to 0, answer 1, and the solve function I call, and I will pass the nums and the goal, right? And now I'm making this here and solve nums and goal. Now I will paste this function here, right? I'm just copy pasting this to make this as so that I can use this function again and again, right? So start 0, here I need to define and also the size of that function. I'm just trying to see make you understand that how the function will work, right? So I will just return an answer here from here. So now this answer has 1, and okay, so I can also do that, right? The summation 0, right? So I don't need this, I just can calculate this nums goal minus 1, and the answer which I will get, I will simply return this, right? Let's see if we pass the test case. It's coming 10. Okay. Here the summation is equals to this goal, and I will simply add a plus plus. So okay, though, so the issue was here that this solve function is what I was doing at this when this goal becomes -1, so it is summation will always be greater than this -1 0, so it will increment that, but it when it's not equals to end, then we are not including that in an answer. So what I can do is we will include this and we will do +1. It's just an implementation part, that before we are not equaling this start and end, so we are not incrementing this +1, but the issue was we when we go into this while loop, then for -1 and 0 case, so the answer will not be included due to that. So I need to just include this answer in it, and this equals to the same. Now I think this should work. They are just passed, so I hope that will not give an error. Yeah, right. Yeah, it's not given. It's just an implementation part at for the -1 case. I've just forgot to implement that. So its time complexity will be, so the first we have included our hashing approach. From there we are going into sliding window, which is not normal sliding window. For that I need to do some changes, that we will find the number of subarrays for atmost at goal, sum is atmost at goal, and find also the summation, and that will the -2, it is equals to this. So some changes in sliding window approach, right? Yeah, so thank you.